next question, we are given a set of 4 different organic compounds and we need to find out which of these can be cleaved or oxidized by HiO4. So let us see the reaction mechanism involved behind oxidation of organic compounds by HiO4.
This reaction is, I think so, one of the most important reaction in the whole organic chemistry, and the most important reaction considering glycols or alcohols as such.
Okay.
Let us see what is the structure of HiO4. Glycol. OH, here R, or whatever. So let us see what is the general mechanism with HiO4.
Yeah.
It forms a structure like this. This alcohol, they bond like this with iodine. This is what they form. It's a 5-member ring,
Right.
between COIOC. And then after formation of this compound, this bond breaks and 1 electron is shipped over here, 1 electron goes here. And this bond breaks, 1 electron goes over here, 1 goes over here, 1 goes over here, and 1 goes over here. This forms plus. So this compound basically will give you one-step oxidation reactions if they are adjacent to each other, or they are if two adjacent carbons, like in the case of glycols, or this reaction will only happen when we have something like this. It gives RCHO plus R dash CHO. It even oxidize aldehyde and keto in same way, and as we know it's a one-step oxidation, so it will oxidize them
To form carboxylic acids. So it is a strong oxidizing agent.
I will not say it a very strong oxidizing agent.
Okay.
One-step oxidizing agent.
Okay.
Then, and the compounds should be adjacent to each other so that they can form a ring and reaction can take place.
Okay.
Even OH and aldehyde are present, so it will also work, and they will be respectively oxidized to aldehyde 1 and 1 will be oxidized to carboxylic acid.
Okay.
Similarly, if trihydroxy are present, then in this case 2 moles of HiO4 will be used, and as this will break, this will break, this 2 will get one-step oxidation.
Yeah.
So they will form RCHO plus RCHO, but this compound, it is getting oxidized twice.
Okay, so it will get further oxidation.
So for only this compound, it's like a 2-step oxidation. So first it will get oxidized to an aldehyde and then to carboxylic acid. So it will form methanoic acid.
Okay.
And if the conditions are warm, we know that a methanoic acid doesn't exist. It exists then as CO2 and H2O, because methanoic acid decomposes to form CO2 and H2O. And finally, if we have a compound like this, it will form plus keto and aldehyde, and if we have a compound like this, we know that it will show no reaction because it cannot form a 5-member ring, as we know. And one more important point you can notice over here is that the OH should be in syn position.
Okay.
That is, they either both should be on dash or both on wedge.
Otherwise, reaction won't take place.
Yeah, because the ring formation can't take place.
Okay.
If they are oriented in opposite directions.
Right.
So now let us solve our questions. The first one, I don't think so it will be reacting because it's not adjacent. The second, third one, we know it's anti.
Yeah, so
it
again
will also
it
not
won't
react.
react.
The fourth one has 3 groups, but again they are not adjacent to each other.
Yeah.
So it will also not react. But the first one, the groups are adjacent and it will react. In the same way, lead tetraacetate also shows the reaction, which is PbOAC whole twice. But for PbOAC2, you don't need the molecule to be cis. The molecule can be even trans also, and still lead tetraacetate will work and it will oxidize in the same way.
Okay. So fine, in this question we have covered the reaction mechanism for treatment with HiO4. There are a couple of guidelines which you should keep in mind while finding out the end product. In some of the products, as we have found out, if the conditions are not met, then the reaction won't take place, and if it takes place, it will oxidize an alcohol to an aldehyde and a ketone or a aldehyde to carboxylic acid.
And in this question, previously it should be cis over here, not syn. Sorry for the mistake.
So kindly note this correction. Next we move to question number 7. In this question, a couple of compounds, organic compounds, are given to us and they are heated strongly. So we need to predict what will happen when we'll heat them. Let us see what happens.
So in the first case, let us see what will happen. This is our compound OCH2 CH double bond CH2, and the star marks carbon is, let us consider it to be C14,
The isotope of carbon.
isotope of carbon. We have marked it. Now this has another resonance hybrid, which is like this.
Right.
So now this pi electron, which is electron rich,
Yeah.
it will donate its electron to this carbon, and this will attack over here, and this pi cloud will move over here, and this will come over here. The bond will break and the lone pair from here, the electrons from here will come towards oxygen, forming double bond 4 CH2 CH double bond CH2 hydrogen, and the CH attached here is the asterisk one as we have marked.
Okay.
And now this electron will go over here and this hydrogen will come out, and here its resonance is not maintained, it's broken. It is like this. The circle is not there, the resonance is hybrid.
Yeah.
And finally it forms this compound. Now let us see what will happen in the second, and this reaction is called as Claisen-Schmidt rearrangement.
Okay.
And it is of phenyl allyl ethers. Let us see now what will happen of the second compound. Now the first step in this product of this reactant is also same. Therefore, this one was asterisk one, and it will see the first step. It will form a intermediate like this, where this is CH3 group and this one is CH2 CH double bond CH2.
Correct.
This goes over here, and this one was asterisk one. And now this carbon again attacks over this position, and this pi electron shifts over here, and this bond breaks and it gets a carbocation, and then it will attack over here. So basically what happened above, it's happening twice.
Okay.
So now we are getting a new intermediate over here, which is CH2 CH.
But don't you think something is going wrong in this question if you compare it with the first part?
Yeah, you get it right. Here the CH3 is there, and as here is CH3 is already present, therefore it can't substitute.
Yeah, the hydrogen is not present in that on that carbon atom.
Yeah, therefore the reaction will not proceed. So if the compound might be a different one, a little bit different, then it will have been this with the hydrogen over here.
Okay.
The first, as we told, it should be like this. With a CH3 over here,
Okay.
and now we are having a hydrogen over here, and now this pi bond
Yeah.
is going to attack this carbon,
Okay.
and this double bond is going to be shifted over here. This one was our asterisk chiral one, and this bond is going to break. So we get a new type of intermediate, which is CH2 CH double bond CH2, and as you can see there the shifting has been done 2 times, therefore this comes over here. Initially it was again we did a mistake in the above one because already it was shifted once.
Yeah.
So this should not be the asterisk one. This one should be asterisk one by our basic formula, basic mechanism.
Basic mechanism which we have done.
And now the asterisk part come over here, back.
Yeah.
And we have a hydrogen over here and OH over here. Now the H leaves, giving us
The final resonating structure.
the final structure of final compound, which is CH2, CH, CH2 and asterisk over here.
So fine, we hope you have thoroughly gone through the reaction mechanism which were presented in these two problems. The first problem was relatively simpler and we got the answer in one go. In the second part, since the presence of methyl group hindered the removal of proton and hence the reaction could not take place, we also explained you the case in which the methyl group is absent and only an hydrogen atom is present and how the product is formed in that case. So we hope you are clear with this mechanism. Okay, in the next question, we are asked to find which out of the four compounds given will form yellow shining crystals as precipitate when reacted with a mixture of iodine and sodium hydroxide. So let us see the reactions involved in this case.
We know that yellow shining crystals are formed when we get a PPT of CHIO3, that is iodoform. And we know that this is one of the most important reaction. It is a haloform reaction and it will be used in many questions in coming questions.
Right.
And apart from that, even in JE or JE Advanced, this is the one of the most asked reaction. So let us proceed. Let us go by the mechanism. We know that we have added I2 plus NaOH or KOH, whatever. It's like I2 plus base, so let us be like as I2 plus 2 hydroxyl, giving me a reversible equilibrium of I minus OM minus plus H2O.
Okay.
Now in my compound I am having RCH CH3 OH plus OI, which is an oxidizing agent. Therefore, it will oxidize it to a keto group. This is alpha carbon. Now, we have base OH minus. With the elimination of water,
Yeah.
it will form a carbon 9 at the alpha position. And this will react with the del plus of I and minus and give out I minus to form RC double bond O CH2 I. We know that this RC double bond O CH2I again on reaction with OH minus
Yeah.
forms RCOC HI and again an carbon ion and again an H plus is taken.
Okay.
Again the same process is done. I and I, del plus, del minus, minus I, we are getting R, C double bond O, C, H this times with I2. And similarly, it will go on till we be getting finally R, C, O, H here O minus, and here Ci3, which will give me C double bond O OH. If this bond breaks and this the C bond 1 and 2, between 1 and 2 breaks, and the electrons from this bond goes over here, and therefore oxygen donates its electron over here to form a double bond.
Okay.
And finally, it produces COH plus Ci3 minus, and as we know that acidic, the carboxyl group is more acidic compared to Ci3 minus, so therefore a proton exchange will happen, and it will ultimately lead into C double bond O minus plus CH(I3), which is our yellow
Precipitate.
or shine crystals.
Okay. So in this question, then it means what all options will undergo this reaction?
One more important point about this is that this compounds I am writing, which gives positive iodoform test, they are CH3 with CHOH or CH3 with the C double bond O compounds. And in case of H, you can have equal number or any number of X with them, or a combination of them. And the compounds which doesn't give, which shows negative iodoform test, are CH3, COH.
Okay, the carboxylic acid group and
CH3, C double bond O, Cl.
okay.
Then CH3, C double bond O, that is amide. CH3, C double bond O, OR, ester. Then CH3, C double bond O, O, C double bond O, CH3, which is our anhydride. And even the diketo don't react with it. It's not diketo, it's carboxyl group and a keto group.
Right.
And even CH3, C double bond O with CH2, C double bond O, OAD doesn't react. They all gives negative response to iodoform. So let us see which will give the positive one. We know that the first one will give, the second will give,
Yeah.
and the third and fourth will
Won't
not
give. Okay, so in this question we have explained in detail the reaction mechanism behind the iodoform formation reaction, and we have also enlisted a set of compounds which will give positive and which will give negative iodoform test. Students are required to remember the set of compounds, as it will help in easing out the problems that may be asked in your entrance examination.
Or maybe just remembering the compounds which can give, because they are only two.
Yeah.